Okay. So 7.4, the inverse trig functions. We've actually seen these quite a bit already, and some of this will be a review from 2 days ago when we just talked about some of the highlights from chapter 6, okay? So let's see what we can get through today, and whatever we don't finish today, we can finish up on Monday along with those equation solving problems. All right, so this should look familiar. On Tuesday, we talked about the three main trig functions, the reciprocal ones, and then we also talked about the inverse ones, okay? So for sine theta equals opposite over adjacent, but it also equals the y value on the unit circle. The reciprocal of sine is cosecant, and that is hypotenuse over opposite, and it is 1 over the y value on the unit circle. And then the inverse function for sine is inverse sine, or we could say arc sine. So textbooks and professors will go between which ones they use, so recognize that they're the same thing. And these always help us find an angle. Like at the end, when we do the inverse function, we end up with an angle as our answer. All right, after sine comes cosine. And cosine theta is adjacent over hypotenuse, or it is the x value on the unit circle. Its reciprocal function is secant theta. So we can say secant theta is hypotenuse over adjacent, and it is 1 over the x value, 1 over the x value on the unit circle. The inverse function of cosine is inverse cosine or arc cosine. And same thing when we apply arc sine or arc cosine or inverse cosine, we will end up with an angle as our answer. Last but not least, we have tangent theta. That is opposite over adjacent, and that is the y over x value on the unit circle. Its reciprocal trig function is cotangent of theta, which is adjacent over opposite, or the x over y value of the angle. The inverse function for tangent is inverse tan or arctan. And when we use that, our answer is going to be an angle. Okay? So I know there's so many different names and it gets really hard to remember what's what, but hopefully this chart will help us remember that a little bit better. Okay? All right, I want to talk very briefly about the relationship between a function and its inverse function. So this -1 means inverse function. Okay. You'll see inverse functions again in Calc 1 and also in Calc 2, but it's a good concept to understand. All right, so don't get too bogged down in all the rules down here, but really think about the bigger concept. So when we think about inverse functions, one of the first things that students tell me they know about inverse functions is that you take your x and y values and you switch them. And that's true. When we have inverse functions, we take the x's and y's and we switch them. And what that means is that the domain and range of those functions are now switched. So the domain of the inverse is the range of the original, and the range of the inverse is the domain of the original. That's one important characteristic, okay? So when folks say switch x and y, this is what you're really saying. You're switching your domain and range. Now, another important thing about inverse functions is that it helps you undo something. So that means if I have x and I add 5, then I subtract 5, I should get the same thing I put in, which was x. And so that's what this second part really says, is that if you have the function and then you apply the inverse function, you should get the original value. And if you switch those, like you apply the inverse and then you do the regular function, you'll still get the original value. Okay? And the last thing I want to highlight here is that the graphs of the inverse functions are reflections of each other across the line y equals x. And for those of us who are visual learners, this is actually a really nice way to kind of think about inverse functions. Okay? So let's take a look at how these characteristics apply to inverse sine, inverse cosine, and inverse tangent. And we're going to use these to help us define the domain and range for the inverse trig function and think about the graph for the inverse trig function. Okay, so let's start with sine and inverse sine. So if you took trig, then you should know the graph of sine. And if you forgot it, you should remember it from Tuesday when we talked very briefly about what this graph of sine looks like. Now, the picture that we have here for sine on the left-hand side is just a small piece of the sine graph. We know that the waves continue to go up and down in both directions forever and ever. Okay? If the waves continue in both directions forever and ever, that means that the domain of sine is from negative infinity to infinity. Or sometimes we just say that is the same as all real numbers. What is the range of sine? Meaning, what y values can sine be? And what can it not be?
-1 to 1.
Good. And it's going to include -1 and 1. So I use brackets on both sides. Okay. Now, if I look at the graph, I notice that there's this blue piece that's highlighted here. Okay. And that blue piece, if I reflect it over the line y equals x, will give me this blue piece. Okay. So the first blue piece becomes the second blue piece by reflecting over y equals x. Okay. But to help us see that a little bit better, let's pick a couple of points and make sure for ourselves that the x and y values got switched. So what's the coordinate of this point up here?
Sorry, what was the question?
What is the coordinate of this blue point right here?
Pi/2, 1.
Yeah, exactly. Pi over 2, 1. So since we have this pi over 2, 1, when we switch the x and y values, that means the corresponding point on the inverse function should be 1, pi over 2. Because we take the x and y values and we switch them. Okay? Now this point in the middle is 0, 0, and when I switch it, it becomes 0, 0. And this last point down here has a x value of negative pi over 2 and a y value of negative 1. And so when I switch them, I get negative 1 comma negative pi over 2. Okay? So that's where we get this graph of inverse sine from, or arc sine. Okay? Now, how many folks out there are wondering why this graph is so small? Like it's just like one little piece. Anybody wondering that? Okay, well, it's an interesting question to ponder. Maybe you could wonder that on your own time. Okay, so the domain and the range for inverse sine. All right, so for our domain, okay, our domain for inverse sine is going to be pretty easy to find. All we're going to do is take the range of sine, and that becomes our domain for inverse sine. But let's use our graph to tell us what the range of inverse sine is. All right, because this graph doesn't go up and down forever. It only has a small portion. So what is the lowest y value and what is the highest y value for the inverse sine graph?
Negative pi over 2 and pi over 2.
Very nice. So we've got negative pi over 2 and pi over 2. Okay. So because we didn't flip the entire graph, we just took part of it and flipped it, our range is a restricted range, meaning it's not all real numbers. It's only from negative pi over 2 to pi over 2. That's going to impact our answers when we start to answer some questions, okay? All right, let's talk about the same thing for cosine and inverse cosine. So inverse cosine, I've got this graph. The domain is from negative infinity to infinity because it goes in both directions forever. The range is the same as the range for sine. It's from negative 1 all the way to 1. Okay, so a restricted range. And if we did the same thing where we took a certain piece of the graph and we reflected it over the XY line, we would get this piece. And we can take our range, and the range of cosine becomes the domain of inverse cosine. And according to the graph, what is the range of inverse cosine?
Zero to pi.
0 to pi, very nice. So we start at the lowest y value of 0, we go to the highest y value of pi. All right. Let's take a look at our inverse tangent. So our domain and our range. One of these is all real numbers for tangent. Which one has the all real numbers? Is it domain or range?
Range.
It is the range. Good job. So our range is all real numbers, but our domain is almost all real numbers. We have to account for all the asymptotes there. So it is all real numbers except x cannot equal k pi plus pi over 2. Okay, so it cannot be any odd values of pi over 2. And to be more specific, we're going to say that k is an element. So that's what that letter E stands for. It is an element of the integers, or z. All right, we can take our range and it becomes our domain for inverse tangent. If we look at our graph, this graph goes in both directions forever and ever, so that's why we know our domain is all real numbers. And then our range is going to be from -1 to 1, but this time I'm going to use parentheses and not brackets because it doesn't actually get to 1 and it doesn't actually get to -1. Right? So these are our 3 trig functions and their inverse trig functions in graph form. It would be really important to make sure you know your domain and your range for these. And actually, I'm sorry, that's not -1 to +1. It is -π/2 to π/2. All right. So let's practice applying these two situations. All right, example number 1, we're going to find some exact values. So again, Tuesday's test is a non-calculator test. So you need to be able to show me your reasoning for where you're getting these your answers from. Okay, so when we say find the arcsine of -1/2, our answer should be an angle or a coordinate.
An angle?
It should be an angle, absolutely. And so we're going to need to go back to our unit circle to help ourselves answer this, okay? So this question is really asking us this. Find the angle with a y value of -1/2. How do I know that it's asking me for a y value of -1/2? How do I know it's not asking me for an x value of 1/2?
Because that's his sine and not cosine.
Exactly. The fact that it says sine and not cosine means we want to find the y value of -1/2. So on your unit circle, can you guys find the angle that has a y value of -1/2?
Seven pi over 6 and 11 pi over 6.
Good. Okay. So I'm really glad that you gave me 2 answers because on our unit circle, there are 2 answers. But it's really important that we only have one right answer. Okay, so our one right answer is going to come back to what our range is for arcsine. So we said that our range for arcsine was between what and what?
-pi and pi over 2, sorry.
Yeah, -π/2 and π/2. So visually, what that means is I can only pick an answer from the right half of my unit circle, okay? That eliminates 7 pi over 6 as an answer because it is not on the right half of the unit circle. So if you on test day tell me 7 pi over 6, that's not right. If you tell me on test day the answer is 11 pi over 6, you're actually still wrong. And here's why. This is negative pi over 2. This is pi over 2. Is 11 pi over 6 between negative pi over 2 and pi over 2? Like on a number line.
Is that negative pi over 6?
Yeah, we have to rename this to be an angle between negative pi over 2 and pi over 2. So this one is wrong because it has the wrong name. Right location, wrong name. Instead, we have to say that it is negative pi over 6. Okay, so we went down to negative pi, 11 pi over 6, but another name for that is negative pi over 6. And negative pi over 6 is the correct answer. All right, let's try part B. We've got inverse cosine of negative root 2 over 2. Somebody translate into words what that is asking me for.
Find the angle with the x value of negative rad 2 over 2.
Perfect. Okay. So let's find the angles on the unit circle that satisfy that. And we should find that it is 3 pi over 4. And what's the other one?
Seven pi over 4.
7 pi over 4? No.
5 pi over 4?
5 pi over 4, yeah. Okay. Now, what is the range for arc cosine?
Zero to pi.
0 to pi. So that means I can only choose from the top half of this unit circle. And specifically, my answer needs to be between 0 and pi. And so for that reason, I can eliminate 5 pi over 4 because it's not on top half of the unit circle. Okay. What about 3 pi over 4? Is that cool, or do I need to rename it because it has the wrong name?
I think that's fine.
Yeah, it is fine, right? Because 3 pi over 4 is between 0 and pi over, and 0 and pi. Okay. So in the case of part B, the answer is 3 pi over 4. And we do not need to worry about renaming it. Okay. So sometimes we need to rename it and sometimes we don't. It's important to know when you do and when you don't. All right, let's finish off with part C here. We've got the inverse tangent of negative 1. That means find an angle with y over x of negative 1. Now that means that y and x should be the same number, except they have to have different signs. So which angles make this true?
Is that 7 pi over 4 and 3 pi over 4?
Very nice. 3 pi over 4 and 7 pi over 4. Okay. Our range for arctan is the same as the range for arcsine. It is the top half of the unit, or the right half of the unit circle, but we need to call it something between negative pi over 2 and pi over 2. So we can eliminate 3 pi over 4 because that's on the left half. That's not on the right half. And we have to eliminate 7 pi over 4 because it's the wrong name. But what do we rename 7 pi over 4 as to get the correct name?
Negative pi over 4?
Good. So our answer here is going to be not 7 pi over 4, but negative pi over 4. Okay?
Why do you get negative pi?
Because I count in the other direction. I need a number that's between negative pi over 4 and pi over 2.
Oh, okay. Okay.
Yeah. I know it's such a picky thing, but I think the reason why is we never want to have two possible answers. We want to make sure there's one possible answer so that we can solve different scenarios. Okay? All right, so folks, this seems like a good place to stop for today. I will post these slides along with the video for this part of class